Coming to you live from the Dixon Gym. Foundations of Math 10 and Pre-Calculus. Dance. Dance. Today, section 1.6, the surface area and volume of spheres.
Let me assert my firm belief that the only thing we have to fear is fear itself, nameless, unreasoning, unjustified terror, which paralyzes human effort to
Hi guys, remember to go ahead and get the fill-in-the-blank notes for this section, and we will get down to business. Starting off here, a sphere is a three-dimensional object that is made up of points that are all equidistant, or in other words, the same distance from a fixed center point. And all points on a sphere are equally distant from the very center of that sphere. The line segment that joins the center to any point on the exterior of the sphere is called a radius, exactly like a circle. The formula for the surface area of a sphere is that SA equals 4 pi r squared. And the formula for the volume of a sphere is that volume equals 4/3 pi r cubed. Now, a variation of the sphere that we commonly work with is the hemisphere. Take a sphere, slice it in half, you have half a sphere, a hemisphere. And the surface area of a hemisphere is not simply 2 pi r squared because of the circle on the base. When you cut a sphere in half, you're creating a new circular face which also has an area of pi r squared. So while the curved part on the hemisphere will have a surface area of 2 pi r squared, there's also a new circle to add on, giving you SA equals 3 pi r squared. And the volume of a hemisphere, this is very straightforward. Since it is just half of that of a sphere, instead of it being 4/3 pi r cubed, it will be half, which is 2/3 pi r cubed. And now for two examples. Number one, a sphere has a radius of 8 centimeters. Give its surface area and volume. So consider the sphere and consider its radius being 8 centimeters. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. Again, I want you to write down the formulas every single time. That way you learn them, you memorize them, and you make sure you aren't making any mistakes. So in here we will substitute r is 8. 8 squared. 8 squared is 64. 64 times 4. Oh yeah, 256 pi square centimeters. If you want to take that into a decimal number, multiply that result by pi and get 804.2 square centimeters. Over here for the volume, again, we've got 4/3 pi times 8 cubed. Grab my calculator again. 4/3 times 8 to the power of 3 gives me 682 2/3 pi cubic centimeters, or of course that's milliliters as well. And multiplying the pi into there, if I want to get this as a decimal number, gives me 2,144.7 cubic centimeters. Just that simple. And this next question, the surface area of a hemisphere is 88 square inches. So what is the circumference of its base to the nearest tenth of an inch? Let's consider a hemisphere. Pretend I can actually draw this properly here. And we're told that the surface area is 88. So remember, surface area is 3 pi r squared, and we know that that's going to be equal to 88. So we need to do a little bit of algebra here, solving for r. So we know that r squared will have to be 88 over 3 pi. Divide both sides by 3 pi to isolate r squared, and r will therefore be the square root of 88, and r will therefore be the square root of 88 over 3 pi. Now I'm going to grab my calculator and calculate this. So 88 divided by, make sure when you're dividing two things for the bottom that you put that all in brackets. Otherwise your calculator will divide by 3 and multiply by pi. Got 9.33. I need to square root that result as well, giving me 3.05, etc. So r is approximately equal to 3.05 and a bunch of decimal places. I'm not going to round off yet because I want to calculate the circumference to the nearest tenth of an inch. And if I round off now and I round off again, that gives a lot of error in my answer. Now circumference is equal to 2 pi r. So I'm going to go to my calculator and take that radius value that's on the screen right now and multiply that by 2 pi. And now I'll round this answer off to the nearest tenth. 19.199 goes to approximately 19.2 inches for the circumference of this hemisphere. And now it's time for
Two for you.
First question, get the surface area of the dome portion only of this hemisphere. Who knows, maybe this is the dome for your home on Mars one day. And question 2, find the radius of a sphere with exactly the same volume as a cube with side lengths of 12 centimeters. Fascinating! Well, once again, that's all the time we have for today. So until next time, keep your pencils sharp, and I'll be seeing you in class.